Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about derivatives of implicit functions. Okay, so till far what we were discussing was explicit functions. Okay, where you were given y is equal to function of x, or you can say that y is equal to sine x, and there we were finding out dy by dx, which is cos x in that case. But now we were we will be given the question like this. Let's say x minus y minus pi equal to 0. So this is given to us and we need to find out the derivative of this. So this is basically a implicit functions. Okay, let me take one example, then it will be more clear to you guys. So the question given to us is find dy by dx if x minus y is equals to pi. So one way is to solve for y and rewrite the above as y is equals to x minus pi. So in that way also we can find out dy by dx by differentiating this function, which is 1 because pi is a constant and the derivative of constant is always 0. Alternatively students, as we are given x minus y equal pi, so if I simply apply the derivative on both sides, okay, so by using the u plus v or u minus v rule, I can say that d by dx of pi is 0. Hope you all know that. Okay, so d by dx of x is 1, and this is which we need to find out. Dy by dx it's equals 0. So dy by dx coming out to be 1 from here also. Okay, so as we can find out from here and here. So this is somewhat a different approach. Okay, so here we need to find out the derivatives of implicit functions. Okay, now let's discuss about the derivatives of inverse trigonometric functions. So student, now we will discuss about the derivatives of inverse trigono functions. Okay, so for example, let's say we are given y is equals to sine inverse of x. Okay, so can I write this as x equals sine y? Okay, so if I derivate on both the sides, so what I will get is 1 is equals to cos y dy by dx. Okay, so if I differentiate dy by dx of sine y using chain rule, so what I will get is dy by dx into cos y. Okay, so now I can write dy by dx is equals to 1 by cos y. So where y is given to us as cos of sine inverse x. Okay, so observe that this function is defined only for cos y not equals to 0, because once cos y becomes 0, so the function dy by dx or the derivative will becomes undefined. Okay, so means y is sine inverse x should not be equal to either minus pi by 2 or pi by 2. Okay, because at this function will become 0. Okay, so to make this result a bit more attractive, we can carry out many manipulations. Okay, so I can say that cos square y is equals to 1 minus sine square y, as cos square y plus sine square y is always 1. So I can say that this is also equals to 1 minus sine of sine inverse x. Y is sine inverse x, as you all know, the square of it. So this is 1 minus x square. So now I can write dy by dx is equal to 1 by cos y. So taking the root of this, cos y will get 1 by 1 minus x square. So the derivative of this function dy by dx coming out to be 1 over 1 minus x square. So student, now onwards you just need to remember this only. No need to go into the details how it comes. Okay. Yeah, that you should also remember how it comes, but in the questions you will be needing only the formula to find out the derivative of y equals sin inverse x is 1 over 1 minus x square. Okay, so I am writing down the derivative of some other trigonometric inverse functions here. So let's say the function is cos inverse x, so the derivative f dash x is minus 1 over 1 minus x square, and the domain of this function is minus 1 to 1, the domain of cos inverse x. Okay, so for if function is cos inverse x, the derivative is minus 1 over 1 plus x square, and the domain is R. And if the function is secant inverse x, the derivative is 1 over x into x square minus 1, and the domain is minus infinite to minus 1 union 1 to infinite. And if the function is given to us as cosecant inverse x, the derivative will be x square minus 1 into x. The domain is same as secant. And if the function is tan inverse x, the derivative will be 1 over 1 plus x square, and the domain will be R. Okay, so I have written down here all the derivatives of inverse trigonometric functions. Okay students, and in the next lecture I will discuss some questions based on these trigonometric functions and implicit functions which we have discussed so far in this lecture. Okay, so stay tuned for next lecture on questions based on implicit and inverse trigonometric functions. Thank you students, happy learning, stay blessed.